Hello and welcome. This is Jim Kaufman with Rankin Technical College. So this is week 3 of the Spring 2026 programming course with C#. So as far as assignments this week, we've got a Chapter 5 written test, and we have a little bit of extensive amount of lab work, both parts 1 and 2. And then as far as topics today, I'm just going to go ahead and do a lecture over Chapter 5. Walk through the number 5 guide a little bit, but most of the lecture will kind of cover it, but I'll still go over the guide a little bit. Concept review. What I'm going to end up doing here is I started a few different apps that I'm going to kind of use as a demo. So each one of them will be similar to the Chapter 5 Labs Part 1. It's not going to be the same thing, but it'll be somewhat similar because I don't want to just do all the assignments for you and give it to you. So I'm gonna do a demo of 3 different apps that are very similar to the 3 apps in the Part 1, and I'll make that code available to you so that you can look at that. And actually, my solutions I have may be different than how you do it, and that's fine as well, right? There's always more than one solution. Okay. I kind of make things, sometimes making things more eloquent is great, but it can be a little more difficult to understand. So sometimes I kind of do things a little more basics just so people can kind of understand what's going on. But as we do that, I'm going to kind of go through, some concept review, kind of why we're looking at that. I'm going to also show you maybe a little bit how you can kind of do a little enhancements as far as bolding things, colors, and things like that. And go through kind of debugging using the debugger within Visual Studio and whatever else we can get to on that. Okay, so let me look at the syllabus real quick. So in the syllabus, just want to make sure this lines up. So Chapter 5 of your book, which everyone should have access to through VitalSource now. Have this quick guide, this Chapter 5 quick guide. And all 3 of these assignments, the written test, Part 1 labs and Part 2 labs are all due Sunday by midnight. So, okay, I think that's good. And just looking ahead, I still have to update this. Not saying this could change a little bit here, but we will have a hands-on test next week. Okay. All right. All right. So this is just a lecture to go into the control structures. Okay. So we'll go through this presentation here on control structures. A couple things and don't worry if some of this it's actually a little confusing. And actually, foundations is here twice, but basically just talking about codes executed line by default. So control structures introduce intelligence by breaking that line in to make decisions, repeat tasks, and handle complexity. All right. So yeah, Boolean logic is very important usually when you're using control structures. Actually, it is the most important thing. So basically, deciding if something's true or something's false. If this way or that way, and then based on that, you're going to take some actions, right? So that's the Boolean part of it. The if else is you're going to test that Boolean. If it's this, do this action. If it's not this, so if it's yes, do this. If it's no, do this, right? Or true and false, right? Or is this field equal to this value? If it's equal to this value, true, take this action. If it's not equal to this, take this other action, okay? Then we also have different ways that we can branch things, right? We have what's called switch and patterns, where a switch is basically a switch statement where if something's this value, then we do this thing, right? If it's this value, this other value, we do this thing, right? It's different than the if else statements. It's a different way to do it. Sometimes it all depends on what you're doing, which one to choose. Okay. Next is talking about loops. So sometimes you need to loop through multiple things, right? Multiple things. So you have an array list. You have a whole list of different things, and you have to loop through there until you find something or whatever. Okay. We're going to look into that a lot more tomorrow. All right. Today we'll be doing a lot more of the if else. Okay. If else, and we're going to do a little bit. We're going to look at a little bit of this branching, the switch statements as well. Okay. Here we got flow and scope. Okay. I don't want to get too much into that. Okay. So the foundation of logic, Boolean expressions. So the binary brain, right? Every complex decision revolves to a single value, true or false. So all these relational operators, okay? The double equal sign, right? Is x equal to 5, right? All of these all going to return either true or false. Okay, so this is for testing if something is equal to a certain thing, right? In this case, a number. Is x equal to 5? Is x not equal to 5, right? If it's not equal to 5, greater than, less than, greater than or equal to, or less than or equal to, right? These are your standard relational operators, and we'll be using them. Do want to mention, because it's a common mistake, it's happened to everybody, every programmer I ever knew. Somewhere, sometime you're doing something and you're not thinking about it. It's a little typo, and instead of checking for equals, you just use one equal sign. Well, one equal sign is for assigning a value, right? Assigning a value to a variable with one equal sign. Like when we did a constant for like kilometers to miles, right? Use one equal sign to sign that, all right? And a lot of times in your code, it's easy, especially in some, if you have using if statements, if else statements, instead of saying x equal 5, you say x equals 5. And sometimes it depends on the context of it. It won't even throw an error, but it won't throw an error as far as you won't see that error until you run it and things just don't look right. Okay. But yeah, so be very careful with the double equals and one equal. One equal is for assignment. Double equal is basically you're testing for, it's a relational operator. You're testing for true and false with the double equals. Okay. And then also we have what's called logical operators. And in this case, the glue, right? The glue. It's taking one and then gluing together another one, right? So in this first one, using the and, which is the double ampersand, it's considered strict. Both conditions must be true. X is greater than 0 and X is less than 10. It's gluing these two together, right? Putting them together. So both of these have to be true for this to return true. Usually you're going to have these within a parentheses, right? You're going to have these in a parentheses, and you'll have an if statement. If, parentheses, all of this, and parentheses. So if that's true, then you're going to execute some action based on that, right? If it's false, you're probably going to execute some other action. Now you have or. Or is a little more flexible. So at least one condition must be true. In this case, x is less than 0 or x is greater than 100. In addition, both to these ands and ors, you can have more than just two. This just has two. This is a compound one, right? These are compound. And it's possible you can have 5, 6, 7 different ones, right? Not that it's always good to do that. You got to kind of question your code if you're doing a lot of those. But, having compound ones are very typical, right? A not sign, right? Just like this not over here on the left-hand side, this operator, right? A not before something. So let's just say you have a variable is valid being true, right? This is going to be inverted. It's going to be the opposite. Now, if for some reason is valid is false, okay? Let's say you have a variable is valid and it equals false. When you do a not between it, it's going to turn it to true. So you always have to don't think of this always as being, like a false thing, because If is valid is true, it's going to return false when you do a not. But if it's false, a not before it is going to return true. It's an inverter, right? It's going to invert that. Okay. So here is selection structures, the if statement. So it's a traffic controller, right? It's directing the program path based on conditions. So here's an example. You're doing if a subtotal is greater than or equal to 200. If that is true, then you're setting some variable. Discount equals 0.25, right? Which is 25%, right? 25% M. So obviously this doesn't have all the code here, but obviously the discount is going to be what? A decimal. If you're using an M, you know it's monetary money, right? Then you know that this is basically going to be a decimal, right? Because that's when you use them. So basically, if subtotal is greater than or equal to 200, that is true. Here you have a discount, right? And so we look at the code over here on the right-hand side. So the important thing here is order does matter, right? So the first one is saying is subtotal greater than or equal to 200. If it is, discounts that. The next one, else if subtotal is greater than 100, right? And the reason it matters, okay, is because you always check the most specific condition first, okay? Now, I do want to mention also why it's very important to have an else here. If you didn't have an else here on this one, if subtotal is greater than 200, it would set this variable discount to 0.25. Then, if this did not have an else and had another if, okay, missing the else here, it's going to do this, and it's going to actually change the discount to 0.20. So even that this was true, and this is what you wanted, right? This would end up getting overwritten here without the else. If you have an else, this won't even be executed, right? This won't even be executed unless, right? Unless this didn't execute. And we'll look at some examples on that. All right. So there's other ways besides if-else statement. It's just a little more complex and maybe, takes a little more to grasp. It's called ternary operators. Right? So it's a way to compress an if-else statement into something else, okay? So here on the left-hand side, you've got a regular if price is greater than 100. You're setting sale price to price times 0.07. Else, so if it's not greater than that, you're going to be setting it to price times 0.08, right? Or 0.8. So this is just a standard if-else statement, okay? Now you can also write this as with a ternary operators, okay? So the way that works is up here you've got a condition, right? And so our condition, the condition is going to be ended with a question mark. So here's the question mark. So here, this decimal, this is just a variable you're giving this, okay? This isn't really the true conditional here. The conditional here is price greater than 100, just like this, right? On the left-hand side with if else, price is greater than 100, you have a question mark after it. So this is your condition, okay? So if it is true, then take price and multiply it by 0.7. Else, this colon here, okay, is the other option, which would be the false option, is price is greater than 0.8, right, times 0.8. So the first part here, price is greater than 100 is your condition. Price times 0.07 is what's going to be executed if it's true. Else, it's going to execute price times 0.8. Okay. Either way, best used for simple. If you have complex if-else statements, it's usually best just to go ahead and do if-else statements. If-else statements are a little more self-explanatory. You can still do it in a ternary operator, but it gets a little messy. Okay, it gets a little messy when you got multiple. So let's talk about branching here, advanced branching, the switch statement. So in this case, this is the classic switch statement. And this is how C# used to do it. And they, updated their program, the C# programming language, and they have more of a modern type expression. Okay, sometimes they're a little harder to understand, but either one will work, right? Either one will work. So a switch statement is basically takes some kind of variable, right? And if the variable, okay, so in this case you got to switch type. So type is something that's defined earlier, okay, and before you reach the switch statement. So let's just, type is a integer with the value of 1, okay? Let's just pretend of that. And so if type is a 1, it's going to set a variable called description to management, and it's going to break out of here. Boom, it's done. Okay, it's not going to continue on. All right, let's just say type is a 0 or type is a 2 or any other number, anything but a 1. Okay, you come in here and you have what's called a default setting. Okay, this is your default. And then what it would do, it would set description here, DSC, equal to staff, and it's going to break out of it. Okay, but you always want to make sure that you have a break. Always include the break when you're using a classic switch statement. But this is just one case. You could have case 2, case 3, case 4, right? All kinds with different descriptions. Okay, but you also always have to have a default one. So it doesn't meet if it doesn't meet any of the other ones, okay, it's going to use the default ones. And it's going to be executed from top to bottom. It's going to check case 1. If case 1, it's going to set it and break. If you had a case 2, it would, and if it didn't meet case 1, it would go to case 2, etc. all the way through. If not, it will execute the default. And like I said, make sure you have a break, because if not, you won't get the results you expect. So here's the modern expression. It's more of a declarative way to do it. Okay, it returns a value directly. Uses these what's called fat arrows. Use these arrows. So basically, same thing here. Here you're actually here's your string description. Okay, and then if instead of having description like this, basically you're just having it in quotes, and then if it will, depending on, let me go back here, depending on which one it executed, it's going to populate DSC with either management or staff. Okay, so basically type is whatever is already defined somewhere previously, right? Type variable, and then it's, in most cases it looks like, because it's it's going to be integer or something, right? Something going to basically be some numeric, right? So you're doing a switch on this, and if it's 1, it's going to be management. Okay, and here's the default. Instead of saying default, you just use the underscore with the fat arrow, and then staff, right? So this is equivalent to what's on the left-hand side. It's just more condensed, right? Just something to get used to. Okay, you don't have to do a break here. You don't have to use the case statement, case keyword, or the default keyword. Them are omitted, right? It's just a shorthand version. Okay, let's talk a little bit about pattern matching. The intelligent filtering, so logic that reads like a sentence using natural language connectors. So type patterns check type and assign variables in one step, right? So you can do if message is string s, right? So this is basically some string, some value that you're passing in, right? That's been defined. And so if this, okay, is equal to something else, right, then that's going to be true, right? You do need to do type check and assignment, right? So that's a type pattern, and we'll look at these more, not so much today, but tomorrow, okay? Relational patterns use logical ranges directly inside of a switch. All right. So you can do something like instead of like you had case one, case two. Well, sometimes you might have multiple, right? If it's one or of two, right? Quantity. If it's a quantity of one or two, right? This may be your discount. So if you only ordered one or two items, your discount's going to be zero. If you greater than equal to three, so three or more, and less than 10, so you have three or more items, but less than 10 items, then your discount's going to be 10%, 0.1, right? Or, and then here's your default. So for anything more than 10, basically, right? Default. So obviously zero would be a bad idea. This could be kind of an error. I could see if your quantity equals zero, it's going to fall down and be here. But that's a whole different subject. Don't want to get into that right now. But yeah, it doesn't look like there's a scenario here that this would not be good. This could be a logic error, but that's okay. I guess you're looking at it from a perspective that you have at least one. All right, that your order contains at least one. But basically, if anything's not one or two or three all the way through 10, right? Then it's going to be a discount of 20% here. Okay, the conditional loops. So there's different kinds of loops. And, we're going to get into loops tomorrow. We're not going to really be doing too much anything with loops today as far as the demonstrations I got planned. But conditional loops, looping when the end count is unknown. Okay. The difference is when the check happens. Okay. A while loop. So a while loop is a pre-test. Okay. And what that means, it checks first and then acts. A while loop. A do while loop acts first, then checks. So a do while loop was always going to execute at least one time, and then it's going to check. Okay. So down here you can see some code. So you're saying while I is less than 10 over here on the left-hand side, while I is less than 10. So it's going to do the check first, right? It's going to do the check first. If this returns true, if I is less than 10, then it's going to go ahead and execute what's in the curly braces. On the other hand, a do while loop like this is going to do whatever's in the curly braces while I is less than 10. Okay. Now you might look at that and think, well, how's that? It's still going to, just the way that the do while loop is structured, it's automatically going to execute this before it even checks what's in your while loop. Okay. And this is an important one to kind of always remember. It's a kind of good interview question too. What's the difference between a while loop and a do while loop, right? So a while loop always checks first, right, before it executes the code, right, or executes what's in your curly braces. Whereas a do while loop, okay, it's going to automatically do what's in the curly braces first, then it's going to check, right? It's going to check the condition. Here's a for loop. Precision looping for loops for arrays, list, and fixed counts. So this is kind of when you already know kind of what you're dealing with. Sometimes when you don't really know how many things you're dealing with or whatever, for loops are not the best to use. Okay. But in this case, like you're looping through something, I want to loop through this 10 times, right? So one thing to kind of realize here for C# and many other programming languages is that many things are zero based. It starts at a zero. Okay, your first thing in your list is at the zero location. So the first thing is at the zero location, right? So this is your initialization. You have integer I equals 0. All right. The second part here is your condition, the rule to keep going, checked before every iteration. So usually at this for loop, you're going to have code underneath this, right? You're going to usually have a curly brace, open curly brace, and an end curly brace in this for statement. You're going to be looping, doing some logic, right? You're going to be executing some code, right, for basically 10 times here. Is I less than 10, okay? So it's going to start at 0. 0 is going to be the first. 9 would end up being the less. Once I is 10, it would come back up here. I is 10, right? And then it wouldn't execute anymore, okay? It's going to only execute 10 times here. But the first part is the initialization. You initialize the variable to 0. Here's your condition, as long as I is less than 10. And here's your increment, how to advance. Happens after the code block runs. After the code block runs once, it's going to take I. Plus plus is going to add 1 to it, right? So the first time you come in here, I is going to be 0. After it executes your code and comes back in here, it's going to increment it by 1, right? So now I will be 1. All the way up until I is 10. Once I is 10, it's going to say, nope, 10 is not less than 10, and it's going to finish your loop, right? It's going to fall out. Controlling flow, interrupting the loop. So to stop a loop, use a break statement, okay? So usually somewhere in your loop, you've got an if statement, say if this, like maybe you're looping through something, a whole list of something, and once you find that, you don't want to keep looking, right? You're done. You're looking to find one thing. Maybe you've got an array of like 100 different things, and once you find it's the third thing, you find it, you don't want to loop through everything else. You don't want to continue that loop. You're done. So once you find it, if found, do a break, and it will break out of that, right? Kind of the eject button, so to speak, right? Now continue. So, and we'll take looks at examples of this. So with a continue though, you basically are like, if you have a lot of code, right? It's going to, you can be doing a bunch of stuff, and at some point within that code, you can be looking for something, and if you find it, you do a continue. You don't want to stop. You just want to go to the next iteration. So you just stop executing what code's there and go to the next iteration. And we'll look at an example on that, because I know that can probably be a little confusing. But it stops the current iteration and jumps back to the top and just keeps on going from there. Block scope, the container rule. So variables live and die within their defined braces. So this is very important. So like like for methods and that, we have like an on-click event. So when you define a variable in that on-click event, once you're gone from that, once that on-click event, once that finishes, that variable that you define there is gone, okay? Now there's ways to define them at the top, right? The top of your classes, so you can still, and we'll be doing that here. We'll be looking at some examples where we do that, because, once you execute like a method, and once that end curly brace, if you define a variable there, it's no longer accessible, okay? So variables declared inside a loop are an if statement. If variables are declared inside a loop or an if statement are invisible to the rest of the program. Okay, yeah, this is talk about more than I was just kind of saying a method, but also with an if statement. So if statements have curly braces, right? And then also loops like the whiles and the fors, they're going to have curly braces. Whatever you define within that block, right? A block is basically any time you have a curly brace and an end curly brace, right? So any kind of block, an if statement, a loop, if you defined a variable, you created a variable there. Once that block is done, it could be in the same method, right? It could be in the same method. Once that block is done, that variable is not accessible anymore. So I'm going to show you a little bit about debugging here again today. So basically, you can set breakpoints. You might have done it by accident. And by default, our apps are within Visual Studio actually run. They actually run in debug mode by default. It's not going to stop at anything though unless you had a breakpoint. And sometimes you might have done it by accident, put a breakpoint. But we'll go through that and how to execute line by line breakpoints. And I'll also show you, how we can print some things out as well. Okay, so here's kind of a syntax cheat sheet, quick reference for operators and structures. So for relational operators, you got the double equals. You have not equal. You have the less than sign, the greater than sign, the less than in equal, or the greater than equal. These are all called relational operators. Okay. Your logical operators are the and, the or the not. Okay. And remember that the not is the inverse. So if the thing that you're checking against is true, it's going to change that to false. Right? It's going to return. It's not going to change it. It's going to return false if you're checking that. Right? If the thing is already false, it's going to return the value of true. Okay. And then also remember, as far as the double equal sign is a relational operator, one equal sign is an assignment operator, right? It's how we assign variables and things like that, and other things as well, right? But for assigning variables, you're going to use one equal sign, okay? This is just relational operators. You're testing. You're checking for equality, or right? You're checking if something's equal. It's always going to return a true or false, okay? Selection, different ways to select things is using an if or else, if-else statements, right? You can have an if without an else. You don't necessarily have to have an else. You do have to be careful with if statements because if the first thing executes and then you're asking, you have to watch your logic errors in that, because if you have an if statement, you may not want to do the one, right? You may have, if that one is not true, you may want to do the next one, but there's sometimes you don't want to. So we're going to look at that as well. Switch statements are all about having the case and the break, right? This is more the traditional way, the older way, where you have the case and you have to say default. It's a little longer, right? The switch expression, use the equal arrow keys, right? And this is much more condensed, and but you just have to kind of understand it. Maybe it takes a little more to understand it, but it's a much more condensed way to do it, right? This is the more modern approach, using a switch expression as opposed to the switch here, right? If and else's haven't changed that much over time, and then iterating through something, right? You could have a list. We haven't, we're going to be learning about arrays here soon, but arrays is a kind of a list of a whole bunch of different objects, right? So you can have a list of, concert names, right? A list of, colors, right? And you're wanting to iterate until you find something in there, right? So the different kinds of ways to iterate, you can do a while. So always remember, a while checks the condition first before it executes any code. A do while is going to execute the code one time first, then it's going to check, okay? And then we have also a for statement, right? And the for statement is where we initialize the value, and then we do a condition to check, right? And then after that, there's three parts of a for statement, right? The initialization, right? Then we do the condition, and then we increment or decrement. You can actually do either one, okay? And then there's also the idea of a jump, right? So you're executing some code. If some condition happens, you may want to break. If you break, it's just going to break out of that loop altogether, right? So you could be looping through a number of 100 things. Once you find it, you got it. You don't need to go continue. You could break, right? But then you also might have another loop where you're looping through a bunch of things, and based on some things, you might have some complex code, and based on some things, you want to skip that one, right? Well, we want to process all of these, but this one we were going to skip, right? So basically, with that, you do a continue, and if some condition happens with that, right, then you just continue to the next iteration. You're still stay within the loop, right? Continue will stay within the loop. It's just going to stop executing where you're at within the code, okay? And then go to the next. Break is just going to break completely out of that loop. Okay, and here's just some debugging shortcuts. You got to watch stepping into stuff. It can be a little bit confusing. We should probably, it's best usually to keep it kind of simple as far as debugging. When you start stepping into stuff, and I'll show you that, it takes a lot of knowledge to really understand some of that, and you know, it can be kind of confusing. But these are just some of the shortcuts for that. You don't necessarily have to use the shortcuts. You can just click on the things as well. Okay, choosing the right tool. So mastering control structures is about efficiency, readability, and robustness. So use if else. So for ranges, so like if it's between this value and that value, right? Complex booleans, right? Where you've got this and this or this, you can have some very complex stuff where you have a mixture of ands and ors. We just looked at and by itself and or. Sometimes you can have ands and ors and multiple conditions that are in separate parentheses, and it can become very it can become very complex. So if else are better for that, okay. And then simple binary choices. It's either this or it's that. Let's keep things simple, right? Use a switch for discrete value list, right? So I think we looked at an example when we had like one, right? You know, well, one thing's probably not best for a use switch, a switch statement. Usually it's got multiple things. And so, you know, if this case, do this. If it's case, you know, A, if it's case B, C, D, you know, a handful of them, right? And then you always have to have your default one. So remember, with switch statements, doesn't matter if you use the old style or the newer expression style, you have to make sure you have a default one, right? That's like the last one in your list. If it doesn't meet any of the other ones, then you go ahead and use your default one. A while statement. So you use a while statement when looping until a condition changes. Okay. So it's kind of an unknown duration. So there's some certain circumstances where you don't know how long you're going to be looping through something. Okay. So, you know, how many things are in something, you don't know, right? So that's when you could kind of, you know, use a while loop. Okay. So let's see what we're going to look at next. So that's the end of that. I think I'll go through the guide a little bit here. So I know this is a little redundant, but, and I'm not going to go through all these. We kind of went through this. I do want to mention something that's kind of an error in here. That there's no such thing as an equal sign with like a forward slash, right? This has got to be the not sign, right? Which is the exclamation point and then an equal sign. So that's kind of an error there on that, right? So this would be a exclamation point with an equal sign after it. That is not equal to. All right. I didn't want to go through that. There's some I do want to go. And I've mentioned this multiple times about the common mistake, assignment operator as opposed to a relational operator, right? One equal sign is an assignment operator, two equal signs a relational operator. So we have assignment operators, we have relational operators, which are these, and we have logical operators, which is the and, the ors, and the nots. Okay. So here's an example, kind of have at least a little bit more code here than the presentation. So here you got a combined Boolean expression. So you got a percent, which is already defined, right? So if percent is greater than 50, it is, and is valid, right? And is valid, well, it not is valid, but usually that's a very common thing to do is have the is before valid, right? But basically valid here, so if and valid, so in this case both of these would be true, so that would be, it would execute any code in here, right? In this case, percent is less than 25, or that either can be true. This code does not run, right? because in both cases, percent is greater. That's not going to work. So that wouldn't execute. And then this is the opposite of valid. So is this true? No, this is going to return false, right? So I know this takes a little bit getting used to that. This is going to return false. Okay, this by itself without the not operator is true, but when you put the exclamation point before that, you're doing the inverse of that. So this, and remember everything in this if statement's always is evaluated to true or false, right? Everything in here. So this right here is going to return false. So this is false and this is false. So nothing here would get executed. Okay, just a basic if statement here. Let your program choose which code to execute. Okay. So yeah, let's go through this one a little bit more again. Just so here's basically an if. It's either one of two things. If subtotal is greater than 100, here's your discount percent. Else, here's your discount percent. Right? If else. Right? Here's an if else change where you got multiple. Right? If this, then here's your discount. Right? Now this is where you want to make sure you use another else. If you forget to use, because this is a common thing, new programmers, new students do. Students new to programming, they'll just do it. They won't have an else here. So basically what happens is this first one will execute. It's going to go ahead and set this variable equal to 0.25. And if you did not have the else statement and just had this, right, then it actually overwrite. This is the one you wanted, but since you didn't have the else statement, it's going to set it to this. Okay, and etc. It's going to continue on. And if you didn't have these else at all here, here or here, it would fall through, and before you know it, it would set. Well, this one would be fine, right? So basically, if you didn't have an else here and an else here, right, then it would end up, no matter, it could have been 500, subtotal could have been 500. This is what it ended up setting it to, okay, because you didn't have an else. These do not get executed unless this is false. If this is false, if this is true, right, none of this gets executed. Okay, that's important to understand. So, order matters. If else chain conditions are evaluated from top to bottom. Once the condition is true, the rest are skipped. Conditional operator. We looked at these already, but at least here we've got some a little better data. Well, we don't have price in that, but that's okay. So all right. So here's kind of more of a realistic switch statement, because I think ours like to have two things. Either it was whatever, management and staff or whatever. So usually for a switch statement to really make sense, you don't want it if you just have like two, because it's going to be if this, else. You just use an if else for something like that, right? Switch statement usually when you have multiple cases. So in this case, if the employee type is a 1, then it's a management. If the employee type is a 2, it's administration, etc. Right? And then always remember, always include a break, so that it'll break out of here. So once it sets this, it's going to break out of here. You're done. Okay. And always have to have default. Yep. So here's the rules. Each case must end with a break or a return. You can also do a return. The default case handles unmatched values. Okay. So it doesn't matter what employee type is. If it's not 1, 2, 3, okay, it's going to be development. So here's the modern approach that we kind of looked at already. So basically 1, 2, 3, same example, right? Just remember default, instead of in the modern way, instead of saying default, you do the underscore, okay? And this is called the discard pattern, okay? So, and this is kind of a newer approach to the pattern matching type. Um, we're just going to do the traditional today more, but we'll look at this tomorrow a little bit. Okay. So here's you got message. You could do is not null, right? Instead of doing, but is not nulls, it's actually pretty easier than just doing the exclamation point equal sign and then null would actually save you a little typing, right? But message is not null and message is string S, whatever is being passed in here, right? All right. We'll look at that more tomorrow. And it's also showing, that you can go ahead and use the relational patterns within a switch statement, right? Which, it's kind of nice here. Instead of doing case one, 1, 2, 3, 4, 5, you do if it's 1 or 2, right? So this is your order. So if it's 1 or 2 items, then it's a 0. If it's 3, between 3 and 10, right, then you're 10% discount. If it's, 10, between 10, 10 equal to or greater than or equal to 10 and less than 25, then it's going to be basically a 20% discount. Anything more than 25 is going to be a 30% discount. All right. Let's see, integer. So loops allow you to repeat a block of code multiple times. C# provides 3 main loop types: the while loop, and the do while loop, and the for, right? So the while loop executes the body, may execute 0 times. It's going to check the condition first. A while loop always checks the condition first. Okay. And whenever you're doing a loop like this, and you need to make sure and especially like a case like this. So here you got integer and you're setting it to 1 and then you're checking it, right? But if you forget to have something that's going to increment your value here, this will go on forever. This is an infinite loop. If you set this and this never changes, this I never changes here, then this loop will continue on until your program crashes. Eventually, your program will crash. So you get some errors and stuff, and you have to close everything down and open it back up again. And a lot of people, I know have been in situations. I would say every developer, especially early on, you learn as you go that you got to be careful about that. But it's easy to do early on, and even experienced people by mistake. So you need to make sure that you're incrementing a value, whatever you're testing for. You got to make sure that there's some scenarios that are going to make sure that that this while loop can be exited, right? So in this case, you're incrementing this, so this is automatically always going, is going to run is less than or greater 10 times, right? So here, you actually set the variable to a 1, so the first one's a 1. So if you remember, I kind of mentioned in a for loop, your initializations, kind of typically you always set that to a 0, okay? You just kind of got to get used to that. It's very common in programming languages, like I mentioned earlier, and especially when you start talking about arrays and things like that, everything's 0-based. Your first thing in an array is going to be a 0, and we're going to learn arrays starting next week. But that's your while loop. A do while loop. So it's automatically going to, so here's a do while loop, and it's automatically going to execute this 1 time. Okay. Then it's going to check this. And like I said, this is always good for an interview question. What's the difference between a while loop and a do while loop? Should be able to answer that. So this is a for loop. And this is best known when you know how many times you want to iterate something. Like I want to iterate this through this 10 times, right? So in this case, it's actually starting at 1, okay? And some people do it like this, okay? Nothing wrong with doing this, but just kind of traditionally, I would say you always kind of, I always learn kind of start at 0. but you don't necessarily have to. Especially there's some things you looping through that it kind of matters, and I'll I'll show you later why that's kind of important because you might want to use I. Let's just say you are looping through a small array. Well, that starts at 0. So if you go ahead and you set this to a 1 at the beginning, and then you loop through array and you use the I, right, as your variable for that array, it's a 1. It's not going to grab the first item in your array. It's going to grab the second item in your array. So there's some reasons, that a lot of times it's best to start with 0 on that. But, people do this, and in certain circumstances, it all depends on what you're doing, okay? But it can cause problems depending on what you're doing. All right. A loop comparison. All right, I'm not gonna. Do want to go through break and continue a little bit still again. So basically, here's a situation where, basically you're looping through this way. Once you find it, right, just like I think I used an example. Then you're saving it. Here's my found index. It's at I, right? So if this is at this I index, which is always going to be a number, right? You're looping through something. So this is an array, right? A bunch of items. Maybe you got 10 items in this array, right? And you're looping through each one. Once you find it, you can say, oh, I found it, okay? And then you can always grab that outside of this loop. But once you found it, you're done. You don't want to keep looping through here. This thing could be, so here you're doing a little differently, right? Up here, when we did our for statement, right? This was our condition, right? And here, it's actually the length of some array, right? We're looping through some array here, right? The length of that array. So we're looping through that. Once we find our search item in that array, okay, we're going to hold on to this. Obviously, this is probably a variable that you defined outside of here, right? Because this isn't defined here, so it has to be defined outside of here. No, this is just a little snippet. And then basically, once you found that index, you're going to break. So you're done. No more iterations. This thing here could have 100 items, right, in it, and let's just say that you found your search value was found the very first one. Boom, it's going to set that index. It's going to break out, and you're done. Right? You don't want to go through the other 99 of them. Now here's a continue, and so in this case, let's just say you're doing something. This is a modulus here. We kind of looked at modulus a little bit on our little egg lab exercise, right? Our egg farmer one where we did modulus for 12, right? But here's one where once you find it, right? Once you skip even numbers. Okay, yeah, this is good for skipping even numbers. So basically, when you do modulus 2, any kind of even number is always going to return 0, right? 2, 4, 6, 8, 12 is always going to return 0, okay? So if I modulus 2 returns 0, right? Continue. So you're basically all you're doing this is you're doing this for odd numbers, right? You're doing this for odd numbers. So you're just continuing on. Yeah. And sometimes you can do, if you've got I haven't mentioned this, if you do an if statement, sometimes it's best to kind of still use curly braces. If you just have one thing, right? If you have multiple things, you're doing, multiple lines of code after your if statement, you need to have a curly brace, begin to end. If you just have one thing like this, you don't have to have a curly brace, okay? Curly braces. But, just be careful with that. It can kind of become confusing sometimes. But here, you basically, anytime you've got an even number, it's just going to go to the next iteration. So like once this is an even number, you come in here and you're looping through, you're at a 2, right? It's going to continue. It's not going to print this. This is only going to print 1, 3, 5, 7, 9, right? All your odd numbers. Block scope, variables declared inside a block are only accessible within that block. So here you've got a for Um, I'm gonna look at this. Temp exists. Yeah. Okay. Yeah. It's just saying. So here you got a for loop. So basically, anytime you just kind of look at it this way, anytime you got an open and closed parentheses, and you've got a variable defined within an open and closed curly brace, not parentheses, within an open and closed curly brace. If you have one a variable, it once you're out of here, once you pass here, you don't have access to this anymore. Okay. Now here it's got a total, and it's just assuming it's not showing an example. That's total is probably defined outside of this for loop, right? So you can this will work, right? How this code's written, right? But this temp variable is just used within this for loop. It's setting that on your total, and usually you got your total defined outside of your for loop. So this works fine, but just mentioning that once you're outside of this loop, this variable is no longer accessible. Same thing here. So this is just an if statement, all right? That one was a for loop. That's a loop. This one's just an if statement. So basically here you've got defined a variable called message. Okay. Once you end this once you end this if statement, once you reach the end of this curly brace, message not accessible anymore, right? So block scope rule: variables declared inside an if, for, while, or any open and closed, right, curly braces block are not accessible outside that block. All right, and I'm not going to do anything with the debugging on this. We can review that. We'll just look at it in the code. And I already mentioned this before, but it's worth looking at again. If else versus a switch. Use an if else when testing ranges. So if x is greater than 12 and less than 15, right? That's kind of a range. That's good to use. For a switch, comparing it against specific discrete values, like we looked at, we had a type, and if it's a type 1 or type 2, right? Discrete values like that, okay? Use an if else if you've got 2 or 3 simple little conditions. If you have multiple possible values to check, switch statements are good for multiple different values. And then also if your conditions are unrelated, you can have where you've got for switch statements, all cases test the same variable, right? You pass in one variable, it's only going to test against that one variable, right? Whereas if statements, you can do if your credit score, because actually I have a demo I'm gonna look at. Credit score, right, could be one variable, and then annual income's another variable, and you're using both of those, right? The conditions are unrelated, right? Credit score, they're two different things, right? So if you need to check two different things, right, then if else statements are better. Okay, I'm not going to mention this again because I've said that multiple times. But and then so come in, look at this. You have any questions? You're wondering what's going on. This guide can be helpful, and so here's some reference cheat sheet. What's necessary? What's needed? Okay. So next here, I will go ahead and start looking at some code. Okay, so now I want to go over the Chapter 5 Labs Part 1. Now I'm not going to do like I've done in the past. I usually doing at least part of labs and that. I'm not going to do that this week, but I am going to do some demonstrations of basically the same concepts. They'll be close to this. Okay, I've got like 3 demo apps. So one for like each one here. It's going to be somewhat similar, okay? Just basically some of the same concepts, and I will make that code available for you, that you can grab that as well. So the first one here for the part 1 of Chapter 5 is a GUI that determines eligibility for college applicants. right? So you're prompting the user for GPA and an admission test score. And then you have basically a button, admit, and then it's either going to be accept or not, or reject. That's not nice, is it? Reject, accept or reject. So um, here you're kind of looks like be what would kind of work here. It looks kind of like maybe something where you're doing maybe an if else statements on this. Okay. Um, but like I said, I'm going to go through a demo that's going to be somewhat here. So like this here, my demo is going to be a little different. I mean, this is going to probably look a lot different for you though. But so I'm going to do like a loan approval one where I'm going to have different credit scores and income. Right. So for yours, you were doing what were you doing there? You're doing a GPA and admission test score. I'm doing my demo is going to have like I said, it's going to have a credit score and it's going to have income. It's going to even be either be approved or denied, right? It's going to be a loan approval type thing. Okay. So, and I kind of reverse generated this from code. I already had example code. So, but I'm gonna go ahead and code this from scratch. Except for I already have the GUI made, so I have the kind of the front end made because it's pretty basic for the most part. But I'm gonna work on the code to the C# code, right, for that. And then the next one here was a hurricane scale. Okay. So basically, category 5 hurricanes, 5, 4, 3, 2, 1. Now, here you're also using, control structures, right? So either, you could do if else statements here. You could do a switch, right? So always remember if something says at least, let me point out that if it says at least, that means less than or equal to, right? At least means less than or equal to. Kind of a hint there. Let me see up here on this other one. Same thing, right? 3.0 or higher, right? That is going to be, GPA is 3.0 or greater, right? Equal to or greater, right? Here's less than, right? Less than 3.0. So that's not less than or equal to, it's less than, right? So really pay attention. Sometimes you can actually kind of write some of this stuff down, take these out of here, and then just kind of, maybe like a little text file. You can kind of think through it a little bit. It's kind of sometimes helpful because if sometimes you just read this and jump into the code and students make mistakes and they do less than or equal to, you got to really pay attention that this is saying less than equal. This is saying 3.0 or higher, right? So GPA is going to be 3 point, greater than or equal to, right? Or higher. Then here on the hurricane thing, at least, right? At least is going to be, equal to or greater, right? All right. And then here, less than. So this is going to be, ain't going to be great. No, no equal to, right? It's going to be less than. So, really watch that. So here's the second one, hurricane scale. And the thing I have, the comparable one, this might go into tomorrow's lecture as well. So I've got a movie rating classifier. So I'm doing a rating for movies, right? So they have an audience score, and based on that audience score, it's either going to be a must-see, excellent, good, average, below average, or skip it, right? So that's what I'm going to be doing. And then here's kind of my business rules for that. Okay. Then the next one in your assignments is number third one here. And yeah, don't get too confused about this. It's just kind of it's just showing you, a way to visualize this. If wind speed is at least, then display this, right? So it's just another view, right? So all of this is the same, right? this applies to this same thing here. This isn't something different. It's just another way to look at it, right? Kind of a more of a visual representation here instead of just words. This other one is a rock, paper, scissors. Okay. So this one will be a little bit more of a challenge. You're going to be using a random C#'s random class. So you're going to be doing a random generator. Okay. Let's see, play 3 rounds of rock, paper, scissors. Once all 3 rounds are over, display the winner. So the comparable one that I'm going to be doing, and I'll make the, like I said, I'll make the code available to you. I'm going to be doing a coin flip game. Okay, so basically it's going to be a heads or tails type thing, and but very similar logic, right? So you're going to guess. You're going to guess either heads or tails, and then we use the random, and that's the computer. Basically, the code is going to be doing a random between heads or tails. So you're going to be kind of playing against the computer, right? Either heads or tails. And then 5 rounds, we're going to do 5 rounds. And after 5 rounds, you display a winner. Either you win or the computer wins, or it's a tie. Well, if we're doing 5 rounds, there never will be a tie, though, right? There will be a tie if there's 5 rounds, because you're always going to have a tiebreaker. So, all right. So let's go ahead and look at the loan approval one. And I'm going to also talk about some other things along the way as well. Just kind of a review of some certain things. Kind of, broaden your depth of knowledge on in some areas. Okay, so I kind of, created already a little GUI. I didn't want to go, I figured no reason to spend the time on that. We've done a few of them, and so I do have a label here without a name in it, but there's a label here, right? Let's see what I gave this. Okay. All right. Let's see. What's on my code here? Sorry, I just kind of... Okay, nothing. That's good. All right. So bring up designer here. So I'm going to go ahead and click on my check eligibility, double click on that to create the click event, right? All right, so for my loan approval, I want to do, so I have some things that I already created. All right, I have a couple text boxes, one for text credit score, and I have another one for text income. So first I'm going to go ahead and parse that, make sure there's something there, right? And then if there is, then I'm going to go ahead and do some logic. So I need to test if the credit score is 700 or higher and the annual income is $40,000 or greater, right? And then or, right? I'm going to have an or, the credit score is below 700 and the annual income is 75,000 or greater, okay? Otherwise, deny a loan. Okay. So in here, what I'm going to do here is I'm going to do an if statement. And we're doing, since the credit score and, since our credit score and our income is going to be, we're just going to look at that as being rounded. So they're just going to be integers, right? We're not going to deal with decimal places or anything. So in this case, we're going to do an int. int dot try parse. And then I want to do our text field, text credit score, text. And I am going to just accept that because that's exactly what I want. So if you're getting some, I don't know, I know some Visual Studios could be configured differently, but this is suggesting this. And if you just want to accept this suggestion, you hit tab here, right? And then I'm going to have tab again, basically tab through, right? Except for that. Okay. One thing you got to watch out for is sometimes either you or something's automated don't always put what you need. So like this is always complaining. So an important thing to always check is make sure like your curly braces are ended. So like you've got that one, right? Where's that ended? So either something's wrong here, right? Something's wrong. So that one here is ended, all right. Okay. This one here is like over here. So something's wrong, right? It's because you're missing a curly brace here, right? It just takes a while to get used to it. Now no issues are found, right? I meant to go through something here, but I kind of forgot here. I was planning on it. So I just kind of want to go through this a little bit again about, what's all going on here with this, okay? So here you got a namespace called demo1. So basically what this does, the purpose of this, the namespace, it kind of creates a container for your code. And it also like prevents conflicts. So let's just say, so here I'm using this form 1 here. Well, what if for some reason, and for what we're doing now, it's not a factor so much. But when you start really getting to coding and you start bringing in other libraries into your code, right? You might bring in some other libraries that you want to use some functionality. And whenever you bring in some other libraries, right, it's going to have its classes too, right? So if you bring in some other library that has the same class as yours, you're going to have some conflict, okay? But when you use a namespace in addition to a class, right, it kind of protects that from happening unless you did the same namespace and that. But usually a namespace, you're going to have something a little more descriptive than this. Sometimes you actually places use their company name, and other things too. It's more complex than that, right? You don't just that simple. Usually, it's something. It's usually going to be pretty unique, but that's kind of the reason to use the namespace to prevent conflicts from other things you may be using. Okay, and it's it's a container for your code, right? So the next thing here is the class definition. So this is your class definition. And so obviously I didn't change the name of mine here. I have on others, but I haven't changed the name here. But, so this has, 3 parts to this, right? So basically the colon form here. So this is basically what's called inheritance. So this means that this is our form, inherits from form, right? And so this form here is a Windows, this is a standard, this is standard behavior of Windows, okay? And it has all these things that's associated with it. So this is see, like when I hover over this, you can see system Windows forms.form, right? So this is a Windows supplied class. Actually, it's an interface, right? But this is a Windows supplied, okay? And so what you're doing is inheriting all of that, right? That way you can actually do where's this defined? This isn't defined in here, right? This ain't defined anywhere in this class. It's because it's part of how Windows handles things and kind of wires everything together. Windows Forms, it's kind of its own little animal, so to speak, its own little unique way of doing things where it kind of wires everything together. So in your class, you know, you don't have to define this, right? This is already known in this class because how Windows wires this all together, okay? And then you have this initialize components. And so this is the basic thing that initializes all your components on the screen. Like I already had some text and, you know, button and some text fields and some labels, right? This initializes all of those, okay? And if we want, just for fun here, let's save this. Let's actually, here, let me run this real quick. See if it comes up all right. Okay, everything's good there, right? I'm going to close that now. I'm going to, just for fun here, I'm going to comment this out. I'm going to save this, and now we're going to run it. So what's going to happen is, since we are not initializing our components, it's going to come up with a blank screen here in this case, right? So there you go. Nothing in there because we're not initializing our components, okay? So let's do something else just for fun here. I'm going to save this again. I'm going to put a breakpoint here. So by default, all of our things are debugged by default. You always kind of really run it in debug mode. So you can always put a breakpoint, right? You do that by clicking over here, right? Whenever you have them, if you do it by accident and you're wondering why my code keeps on stopping at things, well, it's because you probably accidentally have a breakpoint and didn't mean to. So you just click on it to get rid of it, right? So right now I'm going to do that. Now I'm going to go ahead and run this. And this will work for other things as well, okay? So I'll show you some examples when we get into the code here of that happening as well. But right here, I'm going to put a breakpoint here on this. And I'm going to go ahead and click this now. I'm going to start this up. And as you can see, it didn't come up because it's stopping here, right? It's stopping here. And so you kind of got options here on this. You can step over, step into, step out, right? So if I step into, sometimes this can get a little confusing, depends on what it does, but here it's not so bad. So it's going to actually step into our another class that we have, right? That has all of our components, right? Initialize components. Here's all of the components that I already defined for that page, all these ones that are in white. So this is what this is doing, okay? It initializes all of these. If it didn't initialize these, I wouldn't be able to access these, okay? I wouldn't be able to access these within the code later on. So I'm going to hit continue here. And now it's good. All right. So we'll close that. And I'm going to close this and go back to my file. And then you can just go ahead and click on that to get rid of that. I just wanted to show you. That's what's kind of happened under hood. It's kind of important to start understanding more and more about these different things. Okay. So it's initializing all your components on the screen. Now, for the most part, you don't need to add anything in here. Okay. We will later on add some variables up here, okay? Because anything, in this case, we're just doing something pretty basic here, but there might be some instances where we want to have something beyond. Anything you define within this on-click event, once this on-click event's gone, you don't have access to anything. So if there's anything you wanted to save, so some of these labs that you're going to have and some of these demos I'm working, you're going to want to hold on to some data, right? You want to have some variables that you're going to hold on to when you leave something, when you leave a method, right? So we can define them at a higher level so they're available. Anything you define in here is not going to be available outside of this method, okay? All right. So the next thing I want to do in here, so I did that for credit score, all right? What I also want to do is let's see here. I want to do an and. All right, and I want to do another int here, And I kind of wish sometimes my text wasn't as big because it can make things a little more difficult. I can make this smaller for now. But we might need it later, so I don't want to get rid of it all. So, okay, we're gonna do the same thing. So I had credit score, and our other thing was that text, the income, right? Text income field. So here I'm going to do try parse again. Okay, and I'm going to try parse for text income dot text. Oh, got to put it in there the right way. Actually, I could just move this on another line to make life a little easier. Usually if you do that, you should take the and sign with you. Okay. Okay, and then I want to do another out here. And I want to do int. And let's see, I want to do annual income here. And I want to close that. And then here I got to make sure. So here, parentheses, these are always going to, you got to be very cognizant of these. So your parentheses goes from here to there. You probably can't see this on yours, but whenever you put it like after this, you'll see the beginning one. It'll be highlighted a little bit. It's still hard to see, but you'll see it highlighted right here, right? So this one belongs to this one. This one belongs to this one, but you've got this one that hasn't been closed yet. So that needs to be closed, right? So I'm basically saying, so what I'm basically doing here is I'm saying, let's try to parse my text field, right? Credit score dot text. Let's try to parse that into an integer, right? It's going to be a string. By default, it's going to be a string. So let's parse that into an integer, okay? If we're successful, let's go ahead and use an out variable, which is defined as an int, and this is whatever name you're creating. You can call this whatever you want it to call this, right? This, obviously, it has to be the name of your text field that you have on your screen. These here, okay, these here don't have to be, okay? These, you come up with whatever name you want to put, right? These are your out variables, okay? So if this succeeds and it parses this, okay, it's going to parse this into an integer, and it's going to put the value in here and in here, okay? So the next thing we want to do is we're going to do an if statement inside of this if statement, right? So now we've got our data from the screen. Now we're wanting to do an if statement, and I want to do, okay, yeah, it's close, not really, but close. So I want to do if credit score is greater than or equal to, I don't know what's my deal there, 700, and annual income is greater than or equal to 40,000. All right. So that was one condition. The other condition is if credit score is less than 700 and annual income is greater than or equal to 75,000. So here I want to do an or, right? So I do an and here, and then I want to, we're going to be closing that out, but I'm going to do an or here. And I can put the or on this next line. An or is going to be two pipes, right? And then open And I'm going to do credit score here. So then credit score is less than 700. And annual income is greater than or equal to 75,000. Okay. I think that looks good. Now, got an error here, right? So this is just something you got to get used to. Whenever you, so I have an open curly brace, but I don't have an end curly brace. That's my problem, right? So if I go ahead and you can actually see I've got an error right here. It's going to tell you right there what's wrong, right? Sometimes it doesn't always tell you. It depends on the situation. Sometimes it can be very hard. But, you know, you always have to really check your open and close parentheses and your curly braces. Okay? You just kind of get used to it after a while. All right? No issues found now. So now what I want to do, so that was my if. So if either of these conditions, if this and this, or, right, or all of this, right? So this, all of this together has to be true, or all of this here has to be true. If either one of these is all true, right, then I want to set, then this loan will be approved. So I want to do label, result, okay, dot text, I'll just type it, and then equals, and always remember, semicolon at the end. Always remember that when you're setting a label, you need to use a string, right? So in this case, a string literal. It could be a variable though too, right? But you make sure that if it's a string literal, which this is, you need to have it in quotation marks, right? So we have that. So that looks kind of good. So what if it's not approved? So if either of these conditions, it's going to be approved. Otherwise, else, right? What are we going to do here? Else we're going to do label, our label result dot text, and we are going to do a denied here, right? All right. All right, let's see how this looks. Okay, no issues found. That's always good. Helps our screen to come up. So credit score. So if our credit score is greater than 700, so I'm just going to do 800. And our annual income is greater than $40,000. So I'm going to do 40,000,001. Right? $1 over 40,000. We're going to check. You're approved. Okay. And the other, so if we make this greater than equal to, so I could have had that 0 there and it would still work. But if I make it, you know, $30,000, this should say denied, right? And then the other scenario, if my credit score is less than 700, so I'm going to say 650, and my annual income is greater than 75,000, greater than or equal to, so I'm just going to say 74,000, so this should be denied, and that is denied. If I make it 75, this should say approved, and there's approved. Now, some other things you can do here. You know, let's say you just come in here from the beginning. You didn't enter anything. Nothing happens here. Somebody doesn't enter one or the other. You probably should be catching that, looking at that, right? Um, let's see here. So what you could do here on that. So here you got an if statement, and both of this if else statement belong to this, right? And then we can clean this up. Another thing you can always do here too, to kind of help you sometimes, is use these little things to expand and collapse things, right? It helps you see things a little better sometimes, okay? But here we've got, what we can do here on this is we can also have like an error result, okay? And I think, let me go look at the screen here real quick. Let me go back to my screen. I have to kill this. All right. So, let me grab all this. Let's see what I have. So I have two different ones here. So this one here was the result. This is for like an error message here, right? So I already had this defined. Okay, this is just kind of an idea here. I already had this defined, and so I'm going to populate with this the error message. You can do it all in one kind of thing, or you can do it, separate, right? And you don't even have to do this for this lab necessarily. I'm just kind of showing you some different ideas, okay, more than anything else. All right. All right. I regress. Okay, so then here I'm going to go ahead and do an else here. And in this else, I am going to do a... Now this is kind of a preference thing where you want your curly braces. Some people have them at the end. Some people do this different ways, okay? The most important thing, kind of keep them lined up. Depends on how you do it. You can do it here, or you can put that one here and here. But the important thing is, like I said, I just clicked that, and you could see that this one came up, so you know that you're good there, right? So here I'm going to do label, error, result, and I'm going to do .text equals, and I'm going to say, please enter both a credit score and an annual income. We'll close that. And you got to watch that. Sometimes you have extras in there, and sometimes the editor will put them in there. All right. So we have that. I'm going to save that. I'm going to come back up here, run this thing. I'm not going to put anything in there. Please enter both a credit score and an annual income. Okay. You notice mine is red, right? So where'd that red come from? So let's go back in here and let's see, I didn't do it in here. I couldn't have done it in here. I would have seen it. And I will show you that you can also do a lot of the things that you do on within the window, the designer window, you can also do in your code. Now, some things are much easier than other things. Putting things layout and putting one thing here and one thing there, very complex doing that within your code. But like changing font colors and styles and that is pretty not too difficult, pretty straightforward for the most part. Okay, let's get back to designer here. So I had this right? I already have it selected here. Let's go to properties over here. I guess it's not. Okay, so over here, the 4 color, I have this red. By default, if you look like at credit score here, the 4 color, the 4 color is going to be this control text, and this is just some Windows related type things. There's all kinds of different ones here that they have. Okay, these are just kind of Windows suggested, or this is how they, this is part of their color scheme, so to speak, right? But you can do other things as well, okay? And like I said, for me here, wherever that thing was, there it is. I just changed it to red, right? You could change this to, well, you got to watch it. If you just keep clicking, it's going to go to different things. And you could do it just like that and just accept them, or you come in here and change it yourself. Much easier. Hit enter key, and now it'd be blue, right? But I went ahead and set that to red, right? What else did I want to show you while I'm here? Okay, so here, let's put this back to black, or back to regular. I think I right click and do reset. If you have, like, if you're doing different things, I just want to get back to the regular thing. Hit reset. Let's go back to the This is by default. Control text is always black, and that's what it is, right? I'm going to go ahead and save this just because I'm doing different things. Now I'm going to show you a different way to do this. Actually, you do it right in your code. So here you set your text. I'm going to go to end line. I'm going to hit a new line. And then what I can do here on this, for a color, so here I'm going to do the label error result here, right? I'm going to do that. And then I can do dot for color. And here you would do, and you don't have to do this. I'm just showing you this, okay? Drawing, okay? And then here you would do color dot. And I'm going to just do a different color just so we make sure. I know we changed it back to black, but this way we know for sure. Red's always a good color for an error, but just to make sure that nothing went wrong. And so we're for sure using this green one, right? Because I did have it red. I did put it back to black, but just to make sure. So here, would you come over here? Now if I click eligibility, it's green, okay? So whatever you put in your code is going to overwrite what's on in your window designer form, okay? I'd rather it be red though. Okay, so this is just something you can do, all right? And not that you can't reuse the same label result, right? And you can do the same thing, put label result for your error, change this to red, but you do have to watch when you're doing different things. You may have to do resets of those to put them back to what they were before, right? So, all right, that's enough of that. So for this demo, we did the credit score and annual income, right? For your assignment, though, what was your assignment? Let's look at that again. It's going to be a little different. Actually, it might even be a... So I'll put that out there. For yours, you're going to be doing, you're going to be doing a GPA, right? And your admission test score, GPA and admission test score. So somewhat similar. It's just, different things, but kind of doing the same thing as I kind of did there, right? You just have to make sure that you get your logic right, right? What, GPA is 3.0 or higher, right? So that means greater than or equal to, right? So you're going to have to divide, create your code around that. And once you do, you probably get things working, come back and read this again and make sure that you got that right. A lot of times the students, they forget to do the greater than or equal to, or they do everything greater than or equal to. So keep an eye on that. And this is, like I said, this is just a kind of a display, visual display. This doesn't, don't let this confuse you, right? So you got accept, and reject, right? So same kind of concept, you know, if this or this is accepted, kind of the same thing I did for my little demo, else it's going to be rejected, right? Okay, so that's that one. Okay, so the second one is the movie rating classifier. So here basically I have a text audience score, right? So one text box, one button, right? Audience text score, and then I have a rate, get rating button. And I have multiple here, right? Audience score 95, 85, 72, right? All right. Let me see what's in my code here. All right, no buttons or anything. Okay. And so I'm going to double click on this to create the event. And there's our event for button rate click. And then in here, I'm going to do an if statement. And I'm going to do an int because all of these are also just double digit things. You know, you're not using any decimal places or anything. So I'm going to do that. I'm going to do a try parse on that. Right? And then I'm going to do the text audience score. And we're going to do a dot text on that. Just kind of like we've done for everything else here. For the most part, our examples kind of looked at. And then we want to do okay. I'm going to close that. Then don't forget your curly braces. Curly brace there. And I accidentally did that, didn't I? Okay, so we're going to parse that, and then I have my result, right? So my result is going to be here. So here's my result. Let's make sure. Okay, LBL result. So here I'm going to do a switch statement, but I'm going to do label result dot text equals. I want to do audience score switch. Okay. What did I do wrong here? I don't think I did anything wrong. Okay, and then, so I'm going to do the different logic here. So 95, right? Audience score 95 must see, 85, 72, 70. Okay. Yeah, I'll just bring that over here so I have that. That was just test things. Let me look at that again. That was test cases. So I got 90, 80, 70, 60, 50. All right. So here I'm going to do switch statement, right? So this audience score is coming from our out variable. So basically we come in here, we try to parse our audience score, our text audience score. If we're successful, it's going to put it in this out variable, right? Audience score, okay? So this is what we're using as the data that's coming into our switch statement, right? And based on this, we're going to do some, we're going to compare it to some numbers to see what we want to output, right? And our output's going to be put right onto our label. So here I'm going to go ahead and do greater than or equal to 90. And do that. Then we got to do our arrow. And then we do must see. Exclamation point. Okay. And then we're going to do greater than or equal to 80. And then do our arrow. And then we want to do greater than or equal to 70. And we're going to do what on that one. Then we're going to do greater than or equal to 60. Greater than or equal to 50. And then we need to do our default one. Just going to be underscore, arrow, skip it. All right. So one thing on the switch, you need to make sure that you use a semicolon on this. Okay. So we have greater than or equal to 90, must see, excellent for 80, good, average, below average, skip it. We're good there. And so this is for our try parse, and then kind of what I did before on that other one, I'm just going to go ahead and do an else statement here. So if it doesn't, the else is basically if it could not parse it successfully, right? If it could not parse it successfully, then we want to go ahead and do label result. So I'm just putting this right in the other one. Text equals, please enter a valid okay. And then just for fun here, I'm going to go ahead and do the label again. And I'm going to do .for color equals color. Okay, so let's take a look at this. Okay, no errors, no issues found. That's always good. Hit our demo here. So if I'm going to put a 95 in here, must see, greater than or equal to no. So I'm going to put an 80 in here. No, I'm not. So 80 is excellent. 80 or greater. Let's just put it like an 85 in here. Looks good. So 70 or better is going to be good. 60 is going to be average. And then we have 50 below average. And we put a 30 in here. It should say skip it. I'm good there. Then if we go ahead and get rid of it all there and hit get rating, please enter a valid audience score. So this would be somewhat similar to what you'll be doing on yours. Like I said, I'll make these available. The next one's it's pretty much more extensive, and so maybe we'll start that in the next video tomorrow. So that's all I have for today, and tomorrow we'll go ahead and continue with this and go through some of the labs that are part of the part 2 one as well tomorrow. So please let me know if you have any questions, and have a great day.